Hi, in this tutorial we will learn how to create this parametric shelf. I was inspired by this model here, but in this tutorial we will not gonna follow real-world dimensions. At the end you will be able to modify and manipulate many of the properties of this shelf. For example, the width of each section, also the gap between the sections, we can control the number of sections, we can control the height of this part here, and the width, and also we can control the amount of fillet, we can control the minimum extrusion and the maximum from here. We can also switch we can control the thickness of these panels here. So now we can start from scratch. In Rhino, I will add a point. I will bring it to Grasshopper, set 1 point. From curve, I will use the SDL line. It needs a starting point, so I will use this point. Direction, in the X direction, so double click and choose unit X. It needs a length, so I will start with 1.75 for now. You can choose a different value if you like. So what I want to do now is to create an array from this line. So I go to transform, array, linear array. For the direction, it's going to be in the X direction. You can see here by default, it's created 10 copies, and the direction is, which is a vector, it's 10 in the X and 0, 0 for the Y and Z. The direction determines the direction of the array, but also the distance between each copy. It follows the length of the vector, which is here 10. So I want to change that. So I will go to vector, create vector. So in the X, what I want to do is to first, in this first vector, I will give it for the X the same length of the line. And then I will create another vector. I will create a value here, a slider from 0 to 5, let's say. I will keep it 0 in the end, in the beginning. I will add those two vectors together. So here you can see we have this vector here, and this one I will plug it in the direction. Now the 10 lines are touching each other. So what I did here is that in the beginning I want the vector to be equal to the length so they touch. And now if I increase this value, I will create the gap. So I will keep it, let's say, 0.5 for now. Now I will give it a count, how many section I want. So let's say 50. Here I will double click and say even, so that when I change the values, it will give me even numbers, because I need to split this into half, work on the first part, and then work on the second part where the extrusions are happening downward. So I'll keep it 50 for now. So now what I will do is to split these lines into two parts. I will work on the first part, and then I will apply the settings I did here for these extrusions on this second part, but in the reverse. So to do that, I will use from sets, I will use partition list. Here it's asking me for the size of each sublist. So the size should be half of the size of this list. So what I will do is to bring also something here called list length. This will give me the length of the list. I will plug it here, but I will right click in expression. I will type x divided by 2. So the result is 2 sublists, each with 25 lines. So now I want to work on one of them. So I will bring explode tree. Here you can see I have the first 25 and the second, the other 25. So I will work on the first one first, and then apply the settings for the second sublist. Okay, now let's bring an extrude component. Direction Z. Now I need a different value for each of these. So I will bring a range component. You can find it in sets, sets sequence range. This needs a domain, an upper and lower limits, and a number of steps. So for the domain, from math, construct domain. So I will choose a value of 50 for the upper limit. Control C, Control V. Now the number of steps. The number of steps must equal the number of elements. Here, if we look at the result, see by default the number of steps 10. So this is the minimum. You can see it here, and it goes to 50, and the number of steps, see, you can take the difference and divide it by 10, you can get the steps. So I will use list length. And use this as the number of steps. Now, as you can see, I have 25 elements, but here I have 26 values. It's because I divided by 25, I get 26 values. So I will right-click steps in the expression. I will type x minus 1, and now I have 25 number, and I will plug this value to the extrusion. Now I need to work on this part. Now I will use the same things that I did here, but before I will bring move tool and move these in the Z direction downward. I will type minus X, and why I'm doing that, the value that I will put here, let's say for now 5, the value that I'm using here, I will use it to determine the height of the box of these cubes, the height, so that I can change the height, and these extrusions, they should start from here downward. And now I can copy these, Control C, Control V. I will plug these here. I will put the small value in the maximum and the big value here in the starting. And I will right click in the expression and use minus X so that the extrusion happens downward. I can reverse this if I want. I'll bring merge to merge the two extrusions. so that I can apply one extrude component to both of them at the same time. The extrusion is in the Y direction. But I like to have it in the -Y, so again, right click, -X. I will put a value for now 1. Now this part is done. We need these cubes. Let's bring from curve, primitive, rectangle. For the plane, I will choose the YZ plane. And for the origin of the plane, I will choose this point. Now for the size in the X and Y, as you can see, it's a domain. You can see the black hexagon. That means it's a domain. So in the X, it's -1, 1. It's -1 and 1. That means that the dimension is 2. And in Y, it's -2 and 2, so it's 4. If we plug one number, the domain will start from 0 to this number. So for the width, I will choose, let's say, 5 for now. I will right click in the expression, -X, so it goes in this direction. For the Y, I'm gonna use this move that I used here. So I will go to here and bring this value. But I need a -1, so I will use the negative component. I will put this here, so I will press Control Shift and drag it here, and then plug this one here. So now if I choose this value, you can see that now I need to fillet this part. So I will go to curve, utility. I have 2 fillets here. I will choose this one because this one will fillet all the corners. This one will let me choose the corner that I want. So I'll put the rectangle here. For the radius, I will start with 2 for now. So for the parameter, it determines where on the path you are currently placed. To make it visual, I will choose this component point on curve. You can see here 0, it's the beginning of the path of this rectangle. Now when I drag it, you can see that it goes from 0 back to the same place, 1. If you imagine this rectangle like opened one line, so this is the beginning and this is the end here. So I will choose a value between 0 and 1. Now here, by default, this component reparameterized the rectangle by default. This is how it works internally. But here I need to right click and choose reparameterize. The reason is that when I do this, now we are dealing with a domain, with an interval between 0 and 1, and not the actual length of this rectangle. So what will happen now is that if I'm using this point here, if you are closer to this corner will be filleted. So you can see that the fillet is changing corner. So I can choose 0 or 1 because it will be here, or anything close, it will stay. So I have this. Now I can extrude. In the X direction. The value of the extrusion, the amount, should equal the length of this ST line. So I will bring the value from here. I will cap it so it becomes solid. And now I will bring the linear array, click Ctrl C, Ctrl V. I will keep all the values, just change the input geometry. And that's it. We're basically done. We can give it colors, preview, custom preview. Swatch. I can hide now everything. Rendered mode. And that's it. So basically that's it for this tutorial. Hope you like it. If you do, please press the like button, subscribe to the channel, and see you in the next video. Thank you.